Tyler Bennett shifted in his seat, trying to find a comfortable position in the ergonomic chair that definitely was not designed for human anatomy. The lecture hall of the Galactic Institute of Higher Learning stretched before him like a massive amphitheater, filled with beings from at least 30 different species. Some floated in specialized atmospheric bubbles. Others sat on crystalline perches. A few existed as shimmering energy fields contained within magnetic bottles. Tyler was the only human in the entire physics program. He was the only human in the entire institute, actually. Earth had just joined the Galactic Council 6 months ago, and he had won the lottery to be their first exchange student. Literally won a lottery. He still could not believe it. At the front of the hall, Instructor Kelmara shifted her crystalline body, light refracting through her faceted form in rainbow patterns. She was beautiful in an alien way, like a living diamond the size of a small car. When she spoke, her voice resonated directly in his mind through the translator implant behind his ear. Today we begin practical applications of multivariable trajectory physics, Kelmara announced. You will calculate the optimal path for a cargo vessel traveling through the Keskian debris field. This is a standard problem you will encounter in your future careers. Tyler pulled out his data pad and stylus. Around him, his classmates were doing the same, though their methods varied wildly. Nimsha, the insectoid student who had been assigned as his study partner, extended 4 of her 6 arms to manipulate multiple data screens at once. Her compound eyes glittered as information scrolled across the holographic displays. The parameters are as follows, Kelmara continued. The debris field contains approximately 4.7 million objects ranging from 2 centimeters to 40 meters in diameter. Current drift velocity, rotational matrices, and gravitational influence data are included in your assignment packet. You must calculate a trajectory that ensures zero collision probability. Zero collision probability. Tyler noted that down. It seemed like an ambitious goal, but he figured they just meant keeping the risk really low. Like those vaccine side effect statistics they used to quote, where the risk was 1 in several million. You will have 3 standard cycles to complete this assignment, Kelmara said. All calculations must be shown in detail. You may use computational assistance, but you must demonstrate understanding of the underlying principles. This assignment represents 30% of your term evaluation. A ripple of concern passed through the classroom. Tyler heard nervous chittering from the methane breather section. Someone's atmospheric bubble wobbled anxiously. Next to him, Nimsha's antennae drooped slightly. 3 cycles, she whispered in her clicking language, which the translator converted to concerned tones. That is barely enough time to establish the initial probability matrices. On Tyler's other side, Vorith released a puff of yellow gas into his containment suit. The tall, willowy being from the low-gravity world of Eston had been friendly to Tyler, despite the awkwardness of never being able to shake hands or make physical contact. I will need to book time in the quantum computing lab immediately, Vorith said. The waiting list will be long. Tyler downloaded the assignment packet to his data pad and started scrolling through it. Pages and pages of data scrolled past. Object positions, velocity vectors, mass estimates, composition analyses, gravitational calculations from nearby stellar bodies. It was a lot of information, sure, but the basic problem seemed straightforward enough. Do not underestimate this assignment, Kelmara warned, as if reading the room's anxiety. Trajectory calculation through debris fields is one of the most complex challenges in practical physics. Many professional navigators spend their entire careers perfecting these skills. I expect you to struggle with this. I expect you to question your abilities. That is part of the learning process. More anxious noises from the class. Tyler glanced around, genuinely surprised by how stressed everyone seemed. It was just math, right? Calculate some trajectories, avoid the big rocks, done. You are dismissed, Kelmara announced. Use your time wisely. I am available for consultation during my office hours, but I will not solve the problem for you. You must find your own path through the debris, both literally and figuratively. The class began to disperse, students clustering in small groups immediately. Tyler heard fragments of conversation as he packed up his things. We should form a study collective, someone suggested in a high-pitched whistle. I need at least 60 hours of computation time, another voice worried. My probability analysis module is still updating from last semester, a third student complained. Nimsha turned to Tyler, her 6 legs clicking against the floor. Tyler, we should begin work immediately. If we start the preliminary calculations now, we might have the foundation matrix completed by tomorrow evening. Foundation matrix? Tyler asked, genuinely confused. Yes, the baseline probability assessment of object positions over time, accounting for gravitational drift, solar wind pressure, magnetic field interactions and collision cascade possibilities. Nimsha tilted her triangular head. Surely you learned matrix foundation protocols in your preparatory education? Tyler thought back to his high school physics class with Mr. Rodriguez, who mostly showed them videos of things exploding and occasionally wrote formulas on the whiteboard. We covered some trajectory stuff. Parabolas and velocity, that kind of thing. Nimsha's antennae quivered in what Tyler had learned to recognize as confusion. But the multivariable integration of chaotic systems? The probability wave collapse calculations. I think we mostly just used estimates and worked backwards from there, Tyler admitted. Estimates? Nimsha repeated the word like it was foreign to her. You mean approximations? But how did you ensure accuracy? We checked if the answer made sense, I guess? Like, if you got an answer that said a baseball would travel 3,000 miles per hour, you knew you messed up somewhere. Nimsha stared at him with her compound eyes for a long moment. Your species calculates trajectory by verifying if answers feel correct? Well, when you say it like that, it sounds bad, Tyler laughed. But yeah, kind of. I mean, we use math obviously, but we don't need it to be perfect. Just close enough. Close enough, Nimsha whispered. She touched Tyler's shoulder with one delicate arm. I must go reserve quantum computing time. I will send you my preliminary work schedule so we can coordinate our study sessions. This assignment will require all our focus. As she hurried away, clicking anxiously, Tyler looked down at his data pad again. He scrolled through the debris field data, quickly scanning the numbers. 4.7 million objects. Okay, that was a lot. But most of them were tiny, just a few centimeters. Those would not really matter for a cargo ship, right? And the big ones, well, those you could see coming and just avoid them. Vorith drifted past in his containment suit. Good fortune, Tyler. I fear we will all need it for this challenge. Thanks, man. You too, Tyler said. The lecture hall emptied quickly as students rushed off to begin their work. Tyler gathered his things and headed toward the cafeteria. He had 3 cycles to do this assignment, which in Earth time was about 72 hours. Plenty of time. He would grab some dinner, maybe call his parents back on Earth, and then knock this out tonight before bed. It was just trajectory calculation through a debris field. He had done harder problems in high school. How complicated could it possibly be? Tyler sat at his desk in his dorm room, a cup of instant coffee steaming beside his data pad. He had finished dinner an hour ago, called his mom for 15 minutes, and now he was ready to tackle this assignment. He cracked his knuckles and opened the debris field data. 4.7 million objects. He whistled low. That was definitely a lot. But as he scrolled through the data, he noticed something useful. The vast majority of those objects were smaller than 10 centimeters. Tiny stuff. Space dust, basically. A cargo ship would have shields for that, right? He made a note to assume standard shielding would handle anything under 20 centimeters. That cut his problem down significantly. He filtered the data to show only objects larger than 20 centimeters. Now he was looking at about 80,000 objects. Much better. Still a big number but manageable. Tyler pulled up a basic graphing program and plotted the debris field in 3 dimensions. It looked like a messy cloud, denser in some areas than others. He rotated the image, studying it. There were some clear gaps, areas where the debris was thinner. A path started to form in his mind, like finding your way through a crowded room at a party. He sketched out a rough trajectory, avoiding the dense clusters. Then he started calculating. Velocity of the ship, check. Average drift of debris in different zones, check. He divided the field into sections, calculated the probability of collision in each section, and added them up. The math was not elegant, but it worked. When he came to complex calculations, he rounded. If something was traveling at 147.6 meters per second, he called it 150. Close enough. If a debris cluster had a diameter of 8.9 kilometers, he called it 9. The tiny differences would not matter in the grand scheme of things. He used formulas he remembered from high school physics. Distance equals velocity times time. Force equals mass times acceleration. The basic stuff. When he needed to account for gravitational pull from nearby objects, he made reasonable estimates based on their mass and distance. He did not calculate every single gravitational interaction because that would take forever and most of them were too weak to matter anyway. After about an hour, Tyler leaned back and reviewed his work. 3 pages of calculations, 1 diagram, and a final trajectory plot. The path he had calculated had a collision probability of about 0.03%. Basically 0. Good enough. He saved the file, stretched, and glanced at the time. Still early. He could watch a movie before bed. Assignment done. 3 days later, Tyler arrived at the study hall for a group review session that instructor Kelmara had recommended. The massive room was filled with students hunched over holographic displays, quantum computing terminals, and probability engines that hummed with power. He found Nimsha at a workstation surrounded by 6 floating screens, each covered in equations that made Tyler's eyes hurt. Her antennae were twitching rapidly, a sign of intense concentration. She had not noticed him approach. "Hey Nimsha," Tyler said. "How's it going?" She jumped, all 6 legs leaving the ground for a moment. "Tyler, you startled me." She gestured at her screens with multiple arms. "I am making progress, but it is slower than I hoped. I have completed the probability matrices for Sector 1 through Sector 12, but I still have Sectors 13 through 40 to calculate." Tyler blinked. "You divided it into 40 sectors?" "Of course. Fewer divisions would reduce accuracy to unacceptable levels." Nimsha pulled up another screen. "Each sector requires individual analysis of object trajectories, gravitational interactions, and collision cascade possibilities. Then I must integrate all sectors into a unified probability field." "That sounds like a lot of work," Tyler said carefully. "It is the only way to ensure zero collision probability," Nimsha replied. Her antennae drooped with exhaustion. "I have been here for 16 hours today. Yesterday I worked for 14 hours. I still do not know if I will finish in time." Tyler felt a pang of guilt. "Do you want to see what I did? Maybe it could help." "You have started already?" Nimsha's antennae perked up with interest. "Please, yes. Collaboration is permitted for learning purposes." Tyler pulled up his 3 pages of work on a shared screen. Nimsha leaned in, her compound eyes scanning the calculations. For a long moment she was silent. Then her antennae began to quiver. "Tyler," she said slowly. "What is this?" "My solution," he said. "I calculated a path through the debris field with a collision probability of 0.03%. "But where are your probability matrices?" "I did not use matrices. I just plotted the debris and found a path around the dense parts." Nimsha pointed at one of his calculations with a trembling arm. "Here. You wrote that the debris cluster diameter is approximately 9 kilometers. But the data shows 8.937 kilometers. Why did you change it?" "I rounded up. Makes the math easier, and the difference does not really matter." "Does not matter?" Nimsha's voice went up an octave. "Every decimal place matters. If you miscalculate by even 0.1%, the cascade effect could result in collision." "But I added extra room in my safety margins," Tyler explained. "See, I assumed the ship would need at least 2 kilometers of clearance from any debris cluster. So even if I was off by a few meters here and there, we would still be safe." Nimsha stared at the calculations. "You assumed. You estimated safety margins." She looked at Tyler like he had grown a second head. "You are guessing." "Not guessing," Tyler protested. "Making reasonable approximations based on available data. It is different." "How is it different?" "Guessing is random. This is educated estimation. I am using patterns and logic to simplify the problem." Nimsha's whole body was trembling now. "But you have not verified each calculation to 6 decimal places. You have not run probability simulations. You have not accounted for quantum uncertainty in particle positions." She pointed at another section. "Here you wrote that gravitational effects from the nearby moon are negligible. But how do you know they are negligible without calculating them?" "Because the moon is really far away and really small," Tyler said. "Its gravitational pull would be tiny. Not worth the time to calculate precisely." "Not worth the time?" Nimsha stepped back from the screen. "Tyler, this is a cargo ship. Could be carrying thousands of lives. Millions of credits worth of cargo. And you determine what is worth calculating based on saving time." Tyler was starting to feel defensive. "My answer works though. Look at the final trajectory. It clears all major debris by safe margins. The collision probability is almost zero." "Almost zero is not zero," Nimsha said firmly. "Zero means zero. Perfect certainty. Your method leaves room for error." "But perfect certainty is impossible," Tyler argued. "There are always going to be factors you cannot account for. A random micrometeorite. A sensor malfunction. Equipment tolerance. You cannot calculate everything perfectly, so you work with what is good enough." "Good enough," Nimsha repeated. She looked genuinely distressed now, her antennae flat against her head. "On my world we have a saying. Good enough is the enemy of survival. My species evolved in crystal caves where one miscalculation meant falling to our deaths. We learned to be certain before we moved. Always certain. Tyler thought about that. He thought about Earth, about humans running across savannas chasing prey for hours, making split-second decisions about which direction to go based on broken grass and instinct. He thought about his ancestors who had to decide quickly whether that sound in the bushes was dangerous or not, because hesitating meant becoming something else's dinner. On my world, Tyler said quietly, we have a saying too. Perfect is the enemy of done. Sometimes you do not have time to be certain. Sometimes you have to make the best choice you can with incomplete information and hope it works out. Nimsha and Tyler stared at each other across a gap that was much wider than the space between their bodies. It was the gap between two species who had learned to survive in completely different ways. Your method terrifies me, Nimsha admitted. Your method would take me forever, Tyler replied. They stood in uncomfortable silence while the quantum computers hummed around them, calculating certainties that humans had learned long ago to live without. The presentation day arrived with a tension that Tyler could feel the moment he walked into the lecture hall. Students clustered in nervous groups, reviewing their work one final time on data pads and holographic displays. Some looked exhausted, their features showing the strain of 3 days with minimal sleep. Others whispered anxiously to their study partners, seeking last-minute reassurance. Tyler found a seat in his usual spot and settled in. He had printed his 3 pages of calculations on actual paper, which had earned him curious looks from several classmates. Paper was considered quaint in most parts of the galaxy, a novelty item rather than a practical tool. But Tyler liked having something physical to hold, something he could flip through without worrying about battery life. Instructor Kelmara entered the hall, her crystalline body refracting the overhead lights into dancing rainbow patterns across the walls. She positioned herself at the front of the room and her mental voice resonated through every translator implant simultaneously. Welcome, students. Today you will present your solutions to the Keskian debris field problem. I will evaluate not only your final answers but your methodology, your understanding of underlying principles, and your ability to communicate complex calculations. She paused, her facets shifting slightly. Who wishes to present first? No one volunteered. The silence stretched uncomfortably. Very well, Kelmara said. Vorith, please begin. The methane breather floated to the front in his containment suit, a holographic display forming in the air beside him. Tyler watched as Vorith's presentation filled the entire wall with equations, graphs, and 3-dimensional probability clouds. The presentation was beautiful in its complexity, like watching a mathematical symphony. I began by establishing a 60-sector grid matrix, Vorith explained, his translated voice calm despite the difficulty of the material. Each sector required independent probability analysis accounting for object trajectories, gravitational perturbations, solar wind pressure, and electromagnetic field interactions. The presentation continued for 45 minutes. Vorith walked through his calculations step by step, showing how he had used the quantum computing lab to run 17,000 individual simulations. His final trajectory had a collision probability of 0.000003%, which he explained was as close to absolute zero as physically possible while still accounting for quantum uncertainty. When Vorith finished, Kelmara's crystalline form glowed with approval. Excellent work. Your methodology is sound and your precision is commendable. Please submit your full analysis to the course database. 3 more students presented after Vorith. Each presentation was similar in scope and complexity. A student named Krishna had divided the debris field into 72 sectors and spent 8 hours per day in the computing lab. Another student, Tolvin, had developed a new probability algorithm specifically for this assignment and spent 2 pages of his presentation explaining its mathematical foundations. Every presentation took at least 30 minutes. Every student referenced quantum computing assistance. Every final answer had at least 5 decimal places of precision. Tyler started to feel a creeping sense of unease. His 3 pages of handwritten calculations suddenly seemed inadequate. He glanced down at his work, at the rounded numbers and estimated margins, and wondered if he had completely misunderstood the assignment. Tyler Bennett, Kelmara's voice cut through his thoughts. Please present your solution. Tyler stood, his paper sheets feeling impossibly light in his hands. He walked to the front of the hall, very aware of dozens of alien eyes watching him. He held up his first page to the projection scanner, and it appeared on the wall behind him. So, I started by filtering the debris field data, Tyler began. His voice sounded too casual in the formal atmosphere of the lecture hall. Most of the objects are really small, just a few centimeters, so I assumed standard ship shielding would handle anything under 20 centimeters. That reduced the number of objects I needed to worry about from 4.7 million down to about 80,000. He heard a sharp intake of breath from somewhere in the audience. He pressed on. Then I plotted the debris field in 3 dimensions and looked for areas where the density was lower. There were some pretty clear gaps, so I sketched a path that avoided the dense clusters. He switched to his second page, which showed his hand-drawn trajectory diagram. I divided the field into regions based on debris density. High-risk zones, medium-risk zones, and low-risk zones. Tyler walked through his calculations, explaining how he had rounded numbers to make the math simpler, how he had estimated gravitational effects rather than calculating them precisely, how he had assumed safety margins of 2 kilometers around major debris clusters. My final trajectory has a collision probability of roughly 0.03%, Tyler concluded. Which is basically zero for practical purposes. The ship would stay at least 2 kilometers away from any significant debris, which gives plenty of room for error in the calculations or unexpected drift in the objects. He lowered his papers and looked out at the class. The silence was absolute. No one moved. No one spoke. Even the usual background hum of environmental suits and atmospheric regulators seemed muted. Instructor Kelmara's crystalline form was flickering rapidly, colors shifting across her facets in patterns Tyler had never seen before. He wondered if it was the alien equivalent of blinking in confusion. "You rounded the numbers?" Kelmara said finally. It was not a question, but her tone suggested she needed confirmation. "Yes, instructor. To make the calculations simpler." "And you assumed the small debris was irrelevant?" "Not irrelevant exactly, just manageable by standard shielding. I figured a cargo ship would have basic defenses against microdebris. And you estimated gravitational effects rather than calculating them. The distant objects had such minor gravitational influence that precise calculation seemed like wasted effort," Tyler explained. "I mean, yes, technically that moon has a gravitational field, but it is so far away and so small that it would barely affect the ship's trajectory. Maybe by a few centimeters over the whole journey. That is well within the safety margins I built in." Kelmara was silent for a long moment. "You describe a collision probability of 0.03% as basically zero. For practical purposes, yes. I mean, that is a 99.97% chance of success. Those are really good odds." "Good odds," Kelmara repeated. Her mental voice carried an emotion Tyler could not quite identify. "Not certainty. Odds." "Well, you can never have complete certainty," Tyler said. "There are always unknown factors. Sensor errors, unexpected debris, equipment malfunctions. You work with acceptable levels of risk." "Acceptable levels of risk," Kelmara said again. Tyler was starting to feel like he was in trouble, though he could not pinpoint what he had done wrong. "Yes, instructor. It is impossible to account for every variable, so you identify the major factors, handle those carefully, and accept that minor factors will average out." In the audience, Nimsha raised one of her arms hesitantly. "Instructor, if I may ask Tyler a question?" Kelmara gestured her permission. "Tyler," Nimsha's voice was careful, almost gentle. "When you say acceptable margin of error, what exactly do you find acceptable?" "Depends on the situation," Tyler said. "For something like this, where we have good safety margins built in, a few percentage points of uncertainty is fine. If it was a more dangerous situation like flying close to a star or navigating through a minefield, I would want tighter calculations. But for this scenario with proper safety buffers, the approximations work." Another student, a floating energy being, pulsed with agitation. "But you have not verified your approximations. You have not tested them against precise calculations. How do you know your estimates are accurate?" "Because they are based on standard physics principles," Tyler said. "I'm not making wild guesses. I am applying basic formulas and simplifying where the simplification does not significantly impact the outcome. It is about understanding which variables actually matter and which ones are noise." The energy being pulsed again more intensely. "All variables matter. Every decimal place potentially matters. This is basic scientific principle. But in practice," Tyler argued, "some variables matter way more than others. If I am off by 0.1% on the mass of a tiny debris chunk, that is meaningless. If I am off by 0.1% on the velocity of my ship, that is important. You have to know the difference." Kelmara raised a crystalline appendage, calling for silence. "Tyler, your methodology is highly irregular. You have presented a solution that relies on approximation, assumption, and what you call acceptable risk. This is unlike any approach I have encountered in 30 cycles of teaching. Tyler's stomach sank. Is my answer wrong, instructor? Wrong? Kelmara's form flickered again. No, your trajectory would successfully navigate the debris field. Your physics is sound, your spatial reasoning is excellent, and your final path is viable. She paused. But your process is deeply unsettling to observe. You treat precision as optional. You embrace uncertainty as inevitable. You decide unilaterally what is important enough to calculate and what is not. That is how humans solve problems, Tyler said quietly. We do not have time to calculate everything perfectly. We never did. So we learn to make good decisions quickly with incomplete information. The lecture hall remained silent. Tyler stood at the front, his 3 pages of handwritten calculations projected behind him, feeling like he had somehow revealed something about humanity that the galaxy was not ready to understand. Tyler was eating lunch in the cafeteria when his data pad chimed with an official message. He nearly choked on his sandwich when he read it. The Dean of Academic Integrity wanted to see him immediately in her office. His stomach dropped. Nothing good ever came from being summoned to see a dean. He made his way across campus to the administration building, a towering structure of flowing glass and metal that seemed to defy gravity. Inside, he navigated the confusing hallways until he found the right office. The door was open, revealing a chamber filled with swirling purple and gold gases contained within invisible force fields. Enter Tyler Bennett, a voice whispered from everywhere and nowhere at once. Dean Wisprem was a gaseous being, her consciousness distributed throughout the cloud that filled the room. She had no physical form, just patterns of color and density that shifted as she spoke. Tyler stepped inside. The door sealed behind him with a soft hiss. He stood awkwardly, not sure where to look when talking to someone who existed as sentient gas. Thank you for coming, Dean Wisprem said. Her voice was kind but formal. Please sit. A chair materialized from the floor. Tyler sat, his hands gripping his knees nervously. I have reviewed your presentation from Instructor Kelmara's class, the dean began. Purple swirls intensified near where Tyler imagined her attention was focused. Your solution to the debris field problem was completed in approximately 1 hour. Is this correct? Yes, Dean. Other students required between 40 and 70 hours of work, supplemented by extensive quantum computing assistance. Yet you completed the assignment in 1 hour using only basic calculation tools. Tyler shifted uncomfortably. I guess I work faster? I don't know. The problem didn't seem that complicated. That is precisely what concerns me, Dean Wisprem said. Gold flecks appeared in her gaseous form, pulsing slowly. Tyler, I must ask you directly. Did you use artificial intelligence assistance? Unauthorized computational tools? Solutions from previous years? The accusation hit Tyler like a physical blow. What? No. I did the work myself. It's all my own calculations. You must understand my position, the dean continued. No student in the history of this institution has solved a problem of that complexity so quickly without significant technological assistance. The speed of your work suggests either exceptional genius or academic dishonesty. I'm not a genius, Tyler said firmly. And I didn't cheat. I just used normal math. The kind I learned in high school back on Earth. Normal math, the dean repeated. Your instructor reports that you used approximation, estimation, and what you called acceptable margins of error. These are not recognized academic methodologies. They're human methodologies, Tyler protested. It's how we solve problems. We don't need everything to be perfect. We just need it to be good enough to work. The gaseous forms swirled more rapidly, colors mixing and separating in agitated patterns. Tyler, I'm trying to understand. But you must see how this appears. A student completes in 1 hour what takes others days. He uses methods no one has seen before. He cannot explain where these methods came from except to say they are normal for his species. Tyler took a deep breath, trying to organize his thoughts. Okay, let me show you. Give me a problem. Any problem. I'll solve it right now, right in front of you, so you can see I'm not cheating. Dean Wisprem was quiet for a moment. Then a holographic display appeared in the air between them. Very well. Calculate the orbital decay of a satellite around a planet with irregular mass distribution. Here are the parameters. Tyler studied the display. Mass of the satellite, initial orbit altitude, atmospheric density, irregular gravitational field data from the planet's uneven core. He pulled out his data pad and started working. The planet's mass is listed as 6.428 times 10 to the 23rd kilograms, Tyler said as he typed. I'm going to round that to 6.4 times 10 to the 23rd. Close enough for this calculation. He watched the Dean's gaseous form ripple with what might have been surprise but continued. The satellite's orbit is listed at 412 kilometers. I'll call it 400 for easier math. The difference of 12 kilometers won't significantly change the decay rate over the time frame we're looking at. Tyler worked through the problem, speaking his reasoning aloud. He estimated atmospheric drag coefficients based on the satellite's general shape. He simplified the irregular gravity field into 3 zones instead of trying to map every variation. He rounded orbital velocity numbers to 2 significant figures. The satellite will decay and re-enter the atmosphere in approximately 47 days, Tyler concluded, looking up from his pad. Give or take a day depending on solar activity and other factors I didn't account for. Dean Wisprem's colors shifted to deep blue. The precise answer, calculated by our academic computers, is 46.83 days. So I was right, Tyler said. Close enough anyway. You were within 2% of the exact answer using methods that appeared casual to the point of recklessness, the dean said. Her voice carried something Tyler thought might be awe. You rounded away entire kilometers. You simplified complex gravitational fields into zones. You estimated values that should require detailed analysis. Yet your final answer was nearly perfect. It's pattern recognition, Tyler explained. Humans are really good at it. We evolved to make quick decisions based on incomplete information because waiting for perfect information meant getting eaten by predators or starving. Our brains learn to take in data, identify what matters, ignore what doesn't, and come up with solutions fast. This is deeply troubling, Dean Wisprem said, though her tone suggested fascination rather than concern. You are telling me that humans routinely solve complex problems using intuition and approximation? Not just intuition. It's educated approximation. We understand the underlying principles, we just don't waste time on precision that doesn't matter. Tyler gestured at the holographic display still showing the satellite problem. Like, yes, the exact mass of that planet is 6.428 times 10 to the 23rd kilograms. But for calculating orbital decay over a few dozen days, the difference between that and 6.4 is meaningless. It won't change my answer in any significant way. The dean's gaseous form compressed and expanded, like she was breathing deeply despite having no lungs. I need to consult with other faculty. This is unprecedented. Your methods challenge fundamental assumptions about academic rigor and scientific precision. Over the next 2 days, Tyler became the most talked about student at the Galactic Institute. He heard whispers as he walked through hallways. Students pointed at him in the cafeteria. Some looked at him with admiration. Others with suspicion or fear. A group of mathematics professors requested demonstrations of his problem-solving techniques. Tyler spent 3 hours in a lecture hall working through various problems while they watched, fascinated and horrified in equal measure. When he casually rounded pi to 3.1 for a quick calculation, one professor actually gasped out loud. The controversy split the academic community. Some professors argued that Tyler's methods were brilliant innovations that could revolutionize how problems were approached. Others insisted they were dangerous shortcuts that undermined the foundations of scientific rigor. Tyler was in his dorm room trying to ignore the chaos, when Nimsha knocked on his door. He let her in, grateful for a friendly face. I heard the dean questioned you about cheating, Nimsha said, her antennae drooping with concern. I'm sorry, Tyler. This is my fault. I told others about your methods. I did not realize it would cause such trouble. It's okay, Tyler said, though he felt exhausted by the whole situation. I didn't do anything wrong. I just did the assignment my way. Your way is terrifying to most species here, Nimsha said gently. She settled onto one of Tyler's chairs, folding her 6 legs carefully. But I have been thinking about it. About why humans think so differently. Yeah. Your planet is a death world. Category 9 hazard rating. Extreme weather, dangerous predators, deadly diseases, natural disasters. Nimsha's antennae waved thoughtfully. My people evolved in stable crystal caves where conditions never changed. We could afford to be cautious, to calculate everything precisely because our environment was predictable. Earth is definitely not predictable, Tyler agreed. Exactly. So humans evolved to make decisions quickly with incomplete data because that was the only way to survive. You did not have the luxury of perfect information. Nimsha leaned forward. I spoke at the faculty meeting today. I told them that human methods are not reckless. They are adapted to a reality where hesitation means death. You learn to be good enough fast instead of perfect slow. Tyler felt a wave of gratitude. Thanks, Nimsha. That means a lot. There is going to be a formal academic debate tomorrow, Nimsha continued, about whether your methods should be considered valid. Dean Wisprem wants you to attend and explain your perspective. Tyler groaned. More demonstrations? More than that. They want to understand if human intuitive mathematics represents a genuine alternative approach to problem solving or if it is just acceptable carelessness. Nimsha's compound eyes glittered. Tyler, you are not just defending yourself anymore. You are defending your entire species' way of thinking. The grand auditorium was packed with students, faculty, and even some visiting scholars from other institutions who had heard about the human student causing such controversy. Tyler sat in the front row, feeling the weight of hundreds of alien eyes on him. His hands were sweaty and he kept wiping them on his pants. Dean Wisprem floated at the center of the stage, her gaseous form contained in a large cylindrical chamber so everyone could see her. Next to her stood Instructor Kelmara, her crystalline body catching the lights and throwing rainbow patterns across the audience. Thank you all for attending this special academic forum, Dean Wisprem began. We are here to address a fundamental question about methodology and precision in scientific problem solving. The human approach, as demonstrated by student Tyler Bennett, challenges our traditional understanding of academic rigor. Murmurs rippled through the crowd. Tyler sank lower in his seat. However, Kelmara's mental voice cut through the noise. Debate alone will not resolve this question. We require empirical evidence. Therefore, I have designed a practical test that will demonstrate the strengths and limitations of different problem-solving approaches. A massive holographic display materialized above the stage, showing a three-dimensional star map. In the center was a dense asteroid field, rotating slowly. Red icons indicated areas of high debris density. This is a real-time feed from the Tarkos system, 40 light-years from here, Kelmara explained. A mining vessel has suffered catastrophic engine failure and is drifting into this asteroid field. They have limited maneuvering capability but cannot achieve escape velocity. We have been asked to calculate an emergency trajectory that will guide them to safety. The audience leaned forward with interest. This was not a classroom exercise. This was real. The challenge, Kelmara continued, is that we have limited time and limited data. The mining vessel has only basic sensors. Their communication system is damaged, so data transmission is incomplete. And they must begin maneuvering within 30 minutes or they will drift too deep into the field to escape. She gestured toward the display. I am inviting volunteers to attempt this calculation. You will have access only to the data available to the mining vessel. No quantum computing. No probability engines. Just your mind's basic computational tools, and whatever methodology you choose to employ. Several students exchanged nervous glances. 30 minutes was no time at all for the kind of detailed calculations they were trained to perform. I volunteer, Tyler said, standing up. His voice was quieter than he intended, but the auditorium's acoustics carried it to everyone. As do I, Nimsha clicked, rising from her seat several rows back. 2 more students volunteered. Vorith, the methane breather, and Krishna, a reptilian student who had presented one of the most elaborate solutions to the original debris field assignment. The 4 students were brought to the stage and given workstations with basic data pads and access to the real-time sensor feed from the mining vessel. The holographic display split into 4 sections, one for each student, so the audience could watch their progress. You may begin, Kelmara announced. The mining crew is waiting for your guidance. Tyler pulled up the sensor data and immediately frowned. It was messy. Half the debris objects had incomplete mass estimates. The vessel's own velocity had error margins of plus or minus 15 meters per second. The asteroid positions were updating every 30 seconds, but the updates sometimes contradicted previous readings. He glanced at the other students. Nimsha was already manipulating multiple data streams, trying to clean and organize the information. Vorith was attempting to establish baseline probability matrices despite the incomplete data. Krishna was requesting additional sensor sweeps to fill in the gaps. Tyler looked back at his own screen. 30 minutes. A real crew in real danger. No time for perfect data. He started plotting. The vessel was here, drifting at approximately 200 meters per second in this direction. Error margin did not matter much because he would build in safety buffers. The asteroid field was densest in these zones, thinner over here. He marked the thin areas in green. We need trajectory calculations for emergency burn sequences. A voice crackled through the communication link. The mining vessel captain sounded scared. Our drift is accelerating. We're starting to catch gravitational pull from the larger asteroids. Tyler heard Nimsha make a distressed clicking sound. I cannot complete the probability matrix with this data quality. There are too many unknowns. Request additional sensor time, Krishna called out. We need better mass estimates for debris objects in sectors 4 through 7. Negative, the captain's voice responded. Sensors are running on emergency power. We can give you basic position data only. Tyler tuned out the other students and focused. He drew a rough path through the green zones, the areas where debris was thinner. The vessel needed to turn 30 degrees to port and burn engines at 60% thrust for 40 seconds. That would push them toward the gap. Then coast for 3 minutes while drifting through the thinner section. Then another burn, 20 degrees starboard, 40% thrust for 30 seconds. That would angle them toward open space. He ran quick calculations to verify the thrust numbers would not overstress the damaged engines. He checked that the path kept them at least 500 meters from any debris cluster larger than 50 meters. He added an extra safety margin for sensor error. 15 minutes had passed. Tyler transmitted his solution to the mining vessel. Received, the captain said. Is this the final calculation? Tyler hesitated. His path was not perfect. He had made dozens of approximations. But it would work. Probably. Almost certainly. Yes, Captain. Execute those burns and you'll clear the field. In the audience, someone gasped. On the display, Tyler's workspace showed only 2 pages of calculations and a hand-drawn trajectory map. Meanwhile, the other 3 students were still deep in their work, screens filled with equations and probability clouds. Human student, the captain's voice was uncertain. Your solution came very fast. Are you confident in these numbers? Tyler thought about lying, about pretending to certainty he did not feel. But that was not the human way. Captain, I'm confident enough. My calculations have safety margins built in. The path I gave you will keep you clear of major debris. I can't promise perfection, but I can promise you a real chance. A chance is better than drifting into the field, the captain replied. Preparing to execute first burn. The holographic display zoomed in on the mining vessel. Tyler watched, his heart pounding as the small ship's engines flared. It began to turn, slowly at first, then more decisively. 30 degrees to port, exactly as he had calculated. First burn complete, the captain reported. We're angling toward the gap you identified. The auditorium was completely silent. Everyone watched the vessel drift through space, moving between clusters of asteroids. Tyler's hands clenched into fists. He had estimated a 500-meter clearance from the nearest large debris. On the display, the actual clearance showed as 470 meters. Close. So close. But enough. The vessel continued on Tyler's plotted course. Second burn. Third burn. Each time, the ship responded as he had predicted, give or take a few meters. His approximations held. His estimates worked. 28 minutes after the test began, the mining vessel cleared the asteroid field and entered open space. We're clear. The captain's voice was filled with relief. Thank you, human student. You saved 12 lives today. The auditorium erupted in a mixture of cheers, shocked whispers, and confused chatter. Tyler slumped in his chair, exhausted. On the displays, the other 3 students were still working on their calculations, trying to account for every variable with precision that was no longer needed. Instructor Kelmara raised a crystalline appendage for silence. Students Nimsha, Vorith, and Krishna, you may stop your work. The emergency has been resolved. Nimsha looked up from her screens, her antennae drooping with exhaustion and something like embarrassment. But I was not finished. I needed at least 10 more minutes to complete the probability verification. And in those 10 minutes, the vessel might have drifted beyond the safe escape window, Kelmara said gently. Tyler's solution was imperfect. It carried risk. But it was timely, functional, and ultimately successful. Dean Wisprem's gaseous form swirled with colors Tyler had not seen before. This demonstration has been illuminating. We have witnessed 2 different approaches to crisis. One seeks certainty through careful calculation. The other accepts uncertainty and acts decisively within it. She floated closer to Tyler. I owe you an apology, Tyler Bennett. Your methods are not careless. They are adapted to a different kind of reality. A reality where time is limited, data is incomplete, and good enough truly is good enough. Over the following weeks, the Galactic Institute underwent quiet changes. Faculty meetings discussed incorporating human problem-solving techniques into existing curricula. Debates raged about the balance between precision and practicality. 3 months later, Tyler stood in front of a classroom for the first time as a teaching assistant. The new course was called Adaptive Problem Solving Under Uncertainty, and it had attracted students from 17 different species. "Welcome," Tyler said, looking out at the eager faces. "This course is going to feel uncomfortable for many of you. We're going to round numbers. We're going to make estimates. We're going to be okay with answers that are close instead of perfect." A student in the front row, a crystalline being like Instructor Kalmara, raised a tentative appendage. "Will we learn when it is appropriate to use these methods versus traditional precise calculations?" "Absolutely," Tyler smiled. "That's the most important lesson. Knowing when perfect matters and when good enough is actually better. Knowing when speed saves lives and when careful calculation prevents disasters." Nimsha sat in the back row, her antennae waving with what Tyler had learned to recognize as amusement. She had been the first to sign up for the course, eager to understand the human approach more deeply. "Let's start with a simple problem," Tyler continued. "You're in a damaged ship with failing life support. You need to calculate how long your oxygen will last. But your sensors are glitchy and giving inconsistent readings. What do you do?" He watched his students wrestle with the scenario, saw them struggle against their instincts for precision and certainty. And he knew that he was teaching them something valuable. Not to abandon their careful methods but to expand their toolkit. To recognize that sometimes in the messy reality of the universe, approximate and fast beats perfect and slow. The human way was not the only way. But it was a valid way. And the galaxy was beginning to understand that survival took many forms.